Hi everyone. So we are going to be not finishing it up, but we'll do the second part of the missing link, and then we're going to finish up the little last bit tomorrow in the next lesson. And for today's, what is it called? Today's learning targets, we're going to be rewriting the quadratic equation in the form of x squared plus bx in vertex form by completing the square. Kind of. We're not going to be writing it in vertex form, but we are going to be solving for x for that, right? And demonstrating the reason behind the method of completing the square, and use the method to determine the roots of quadratic equations of the form ax squared plus bx plus c. That we're going to do. All right. So we're going to now skip ahead. Skip a few, like right here. Oh, perfect. Right in the middle. So now we're at completing the square. This is on page 164. It's like right up here anyways. Okay, and so I did not want you to use technology. I wanted you to just do this by graph this equation by finding the AOS, the vertex, and the y-intercept, right? And this is good practice because I'm going to be expecting you guys to know how to do this later on. So if you look at right here, x is equal to -10. Oh, we figured out what A, B, and C are, right? And so A is 1, B is 10, and C is 12. Still don't need C yet. We will soon. So we plug it all in. Remember our axis of symmetry is 2a. So negative b over 2a, that's going to be the formula. You should have written that down already. And so you get the AO is equal to -5. You do not just say, oh, it's equal to -5. No, it's an equation, remember? So it's going to be x equals to -5 like this. So this is the AOS right here. So since the AOS is a line, you need to write an equation, because the way you write an equation of a line is by having an equation. All right, so here's that -5. Remember, that's our mirror. You always draw that in. And then the vertex, the way we figure out the vertex is, well, we know that the AOS is -5, which means that somewhere on this line lies the vertex. Where? Don't know, so we're going to find out. So inside for this x, we're going to put in -5. And that's what we did here. Because we know that x is going to be -5 because it's on the x equals to -5 line, right? We just need to figure out what y is. So once we plug those in for the x, we're going to just do our order of operations. So nothing inside the parentheses that we can do. So it's going to be -5 squared, which is +25. Some people are thinking it's -25, but it's not. On your calculator, you need to put in parentheses first, right? Or else you're going to get -25, and that's not correct. Because remember, this is -5 times -5. And then we got 10 times -5, which is -50 plus 12. And then you would get that total of -13. So your vertex is -5, -13. Remember, the vertex is a point, so please write it as a point. Right? And notice right there on the line at where y is equal to -13. Now, the other thing is the y-intercept. Remember, this guy right here is the y-intercept. If you didn't remember that, you can logically reason it out, right? What is the value of x on the y-axis? 0. So you just plug in 0 for x, and you just get 0, 0. Oh, we just get 12. All right, and so that's going to be our y-intercept. How did I get this other point over here? Magic. So from this 12 to the y, to the axis of symmetry, that is this distance right here is 5 away, right? Because remember, this is at 0 on x, and this is to -5, right? So that distance is 5 away. So then we go on the other side, 5 away, and that's where we end up at this -10 right here, and that's going to be the symmetric point. Because remember, parabolas are symmetrical. All right, so this is also 5 away, here to here. So if we know a point on one side of the AOS, then we know the point on the other side. All right, and then we just draw the parabola. So we know that the roots are going to be somewhere here. So it's going to be like -1 something, and it's going to be -8 something if I drew it right. I might be a little bit off. So we're going to now go and try and figure that out. We're going to do some completing the square business. So if you have, honestly, I think the best way to teach this, well, there's a lot of different ways. I think the way that, well, and we'll go on. I'll show you this way. So here, in order to get x squared plus 10x, what they did here was they just factored out the x, right? And said x plus 10, right? And then so this is x and this is x plus 10. So we know that the inside is x squared plus 10x. Okay. And then the next part right here is we notice that, so what we're going to do is, this is a rectangle right now, right? And, but the thing that we want to do is we want to change this into a square. So how do we do that? So we're going to basically take this 10x and we're going to split it up. Okay, so if you notice that these two are also yellow, right? So we're going to split it up exactly in half so that it's going to be 5x here and 5x there. The reason why we do that is so that we can have equal lengths to make a square, right? So this is x plus 5 and this is also x plus 5. How do I know it was a 5? Because I knew that this inside was a 5x, right? If I know that this side is x, which means this side has to be 5 because 5 times x is 5x. And if you notice, we almost have a square, but we're missing this little part here. So what would we have to add in? 5 times 5, which is 25, right? And then now we would have a square. All right, so we're going to keep that in our brains a little bit. Okay. I guess the other thing is then from this, we could say that this would be equal to x plus 5 squared, right? Because this is, if we were to find the area of that, this is x plus 5 times x plus 5, right? Okay. Now, we're going to go to this one. So we're going to complete the square like this. I did it with using the crisscross method way, which you can. If you want to do it this way, you can totally do that too. So if we take the 8x and we split them up, right, and we put them over on the sides, just like how we did before, right, they would both be 4x, correct? So here I just wrote down the 4x right here. So I know it has to be 4x and 4x, right, because I'm splitting that up into 2. And then, well, how do I get the 4x? I would have to multiply the x with a 4, right, and this x with a 4. So then that's how we would get 4. Then what does this number have to be then? Well, these two numbers, when they multiply together, would have to add up to this, or not add up, would have to multiply to be 16. Would have to multiply to be this number, right, which is 16. That's what I meant to say. So now adding in the 16, now we can write down a perfect square. And the way we do that is just, remember, this is just going to be going straight across x plus, so this is just x plus 4 times x plus 4, right? In the factored form, if you want to call it that. And so to write this simply, instead of saying x plus 4 times x plus 4, we just say x plus 4 squared, okay? So looks like here, so the way we get these numbers is by, we're going to cut this in half, 8x in half, right? So that we could get a square. And then we're going to figure out what these numbers are here, right? By looking over to the right, like, okay, then those got to be 4. And then, which means when we square them, when we multiply them, that's going to give us this number up here. And then this number is the same as these numbers over here. Hopefully that's not confusing. Okay, same thing over here, same idea. Remember, if we're going to break up the 5x, so we know that this is going to be, so this is going to be the first thing we look at, right? Actually, I'll be like this. We look at the 5x, and then we're going to cut that in half so that we get 2.5x for both. Well, how do we get 2.5x? We're going to reverse engineer it, like by multiplying by 2.5. Well, then this, knowing this, because they both have to be 2.5, they have to be the same. So 2.5 times 2.5, that gives us this, 6.25. And then now we can write down, oh, this guy right here. That, because remember, it's just going to be x plus 2.5 times x plus 2.5. Exact same thing. So that there's that. Okay. All right. So we're going to try that out a little bit. So if you take a look at letter A, right? And again, I would pause here if you did not do these. You were not awake for this. We're not there for that. Either way. So then what would this have to be so that we get the square like this? We know that, oh, I don't know, that's a plus. I know that's going to be an x. So remember, this is going to be x and x. And remember, this is going to be, we just cut that in half. So it's going to be negative 4x minus 4x, right? Which means that both of these have to be negative 4s, right? Because x times negative 4 is negative 4x. X times negative 4 is also negative 4x. So then from here, we're going to multiply these two guys. which would be plus 16, right? Negative 4 times negative 4 is positive 16. And then remember this number, go right there. Done. So that's how we got 16 and x minus 4 squared. All right. And you could practice that for the other ones right here. I show you the work here if you want to see. We didn't do B because B was exactly like this one right here. This B, same thing. All right. So we're not going to do too much about that. We're going to go down here. So to completing the square, to determine roots. Okay. So we're going to use the same concept, but it's going to be slightly different. It's going to look slightly different, but it's the exact same concept. All right, and I like to do it this way as opposed to over here because it looks a little bit strange to me. I feel like they take way too many steps. Okay, so if you look right here, the first thing we need to do is, so if you're given an equation, they're like, solve for x. And you're like, well, I can't factor this because that's what I would normally try first, but I can't factor it. So pretend I tried, okay? And then, so what we're going to do is we're going to make it look like, you know, how we just had that binomial right here with the x squared plus 10x. We're going to make it look like that. So the way we do that is we get rid of the negative, get rid of the 12 by subtracting. So this is like their first step right here, right? So it says isolate x squared minus, ooh, this is not minus 4x, plus 10x. I forgot that didn't work out. So this is like their first step right there, right? All right, and then, so what we're going to do is from here, it would be better if you, I will just rewrite this again. Because technically it should look like this. So we got this part. What I like to do is after this, when we subtract out the 12, you set up the perfect square. This is what I call set up the perfect square. Because this is my perfect square. So when I do that, remember what I do here, that 10, that's going to, I'm going to divide that by 2, right? And so I get plus 5, right? That would be my answer right here. Notice right here, that was my answer. Whatever this was, when I divide this by 2, right? That's going to be this answer over here. Remember, just divide it into 2. All right. So then when I do that, what happens? How do I get this number right here? Well, I take this 5 and I square it, right? I just multiply it by itself because it's like the 5 times 5, right? So this is going to be plus 25. Now I just added 25 to the left-hand side. And you can't just add 25 to one side and just let the other side go and still think that it's going to be equal. That's not the same, right? So then what I'm going to do is I'm going to add 25 to the other side. So that is now equal, right? So this is how you keep it equal. It's just whatever you add on one side, you have to add on the other side. Or if you're subtracting on one side, you got to subtract it on the other side. Just like how I did here. I subtracted 12 on the left-hand side. So that's why I had to subtract 12 on the right-hand side to keep that equal. Or else it's not going to be equal. It's going to be uneven, right? And then so once I do that, now I'm saying that x plus 5 squared is now equal to x squared plus 10x plus 25. They are the same. If you don't believe me, I can show you right over here. So I'm saying that if I were to multiply this out, so this is x plus 5, just like what we did before, right? X plus 5, this is going to be x times x, which is x squared, x times 5, which is 5x. This x times 5, which is also 5x, and this 5 times 5, which is 25. You see? Perfect square. And when I add these guys up, it's x squared, 5x plus 5x is 10x plus 25. Oh, don't forget the x. And do you see how that's exactly the same as what we put up there? It'll give you a perfect square every single time. All right. And so instead of writing it like this, x squared plus 10x plus 25, we're just writing it as x plus 5 squared. So they're equivalent. They just look different. All right. And then what is negative 12 plus 25? That's 13. Just like 13 is the same as negative 12 plus 25, right? They're equivalent, but we're just simplifying it. All right. And then from here, all you need to do is solve for x. All right. So we're going to, how do you get rid of that square? How do you get rid of any square in general? Square root it, right? So that's the way you get rid of any square. And remember, when you're square rooting both sides, you have to add in the plus negative. plus negative, plus or minus, right? And that's why we have this plus or minus right here. And the square root and the square cancel each other out. So they undo each other. So literally you just have x plus 5 left. And what was the whole point of this? Solving for x. So now we're going to subtract 5 on both sides, and we get x is equal to negative 5 plus or minus square root of 13. The standard procedure to put the plus or minus the square root thing at the end. You don't put it in the front normally. And what this just means is this. So if you want to write, if you want to just leave your answer like the way it's written here, negative 5 plus or minus square root of 13, that's totally fine. But if you're like, I want to like, because that doesn't really make sense to me, so I want to write it out like this. And that's fine too. X equal to negative 5 plus square root of 13, and then x equal negative 5 minus square root of 13. Right? We got the plus one here and then the minus one here. I told you this is not like, let's choose your own adventure. It's not like that. It's saying it's both of those guys. All right. So that is our answer. And then we're trying it for this one. And I wrote down some examples, or the, what is it called? The steps here. So to find x using completing the square, right? First set equation equal to 0. Like here, we want to find the roots so that we know that y is equal to 0 at this point. And then what do? You're going to add or subtract the constant, right? So that you can get this binomial right here on this left-hand side. And then we're going to set up the perfect square, right? And then remember half b, square up. I say square up because we're going to take the 4 and we're going to square it up here. And then we're going to add it to the other side. All right, and then simplify. Right, and that's what I wrote here. So half b, right, and then square up and then add same number to the other side and then solve for x by square rooting first, right? Got to remember to do that. So what I would do is I would practice doing that. And if you notice right here, I actually calculated this in the calculator. What I would do if I were a student is put this in the calculator. And you cannot do it all at once at the same time. You can't say negative 4 plus or minus square root of 16. It's not going to give you the wrong answer. Okay, it would be like plus the negative of square root. You don't want that. So again, in your calculator, you're going to put negative 4 plus the square root of 6 and push equals. And then you should get negative 1.55. And then the other one is negative 4 minus the square root of 6. And then you get negative 6.45. That's what you should get. All right. And if you notice right here on the graph, yep, this is about negative 1.55. And this is about negative 6.45. Yeah, do you see? It totally does predict that. Okay. And then so again, try this for A. If you did not try A, try it again. Here's the directions. Right. And for the next one, I will try to color coordinate it. And what I would do if I were you is pause and do a thing. Give your brain a chance, guys. So we already set this equal to 0, so I don't have to start with orange. I will start with green that I don't have. I think this was the green right here. Okay, so I already did this, so I'm going to add and subtract out the constant. So I'm going to go minus 6, minus 6. And I get x squared minus 12x space equals negative 6. And then it says set up the perfect square. I'm like, I can do that. Right below it, we're going to set up the perfect square. I know it starts with an x and there's an equal. Okay, it set it up. And then it says half b. So remember my b is the negative 12, right? So we're taking that negative 12, we're dividing into 2 pieces, equal pieces. So that's going to be negative 6. So I have to be done. Now I'm going to square up. So that's going to be negative 6 squared, which is going to be positive 36. And I say up because we're putting that up here, right? And it says add the same number to the other side. So if I added 36 to the left, I have to add 36 to the right, to keep that equal. And then I'm going to simplify that. Negative 6 plus 36 is going to be 30. Right now I'm going to solve for x by square rooting first. So where's my purple? Okay, here it is. So I got the square, and there's nothing else here, which there shouldn't be. We're going to square root both sides. Don't forget to add your plus or minus. So x minus 6 is equal to plus or minus square root of 30. We're so close. Now we just got to get rid of the minus 6 by adding 6. And then your answer is going to be x is equal to 6 plus or minus the square root of 30. And again, I will give you a chance to calculate this out. Let's see if I could find decimals. No, but I do have this calculator that I can use. All right, so I'm going to clear So if you have one of these guys, that's totally fine. I'm going to clear. Okay, so what you're going to do is you're going to, let's put it right here. So it's going to be 6 plus, so I'm just do, I usually just do the, I just do it in order. So I do the plus first, square root. So if you look at right here, here's a square. The inverse of that is the root, right? That's why it's right above it. So go second square, right? And then you're going to have 30. Or it's going to be like this, and I'm going to press enter. And you get 11.48, we'll say, okay, because 7, if you look at 7, next to it is another 7, which means that that's 5 or bigger, which means it's closer to 8 than it is to 7. All right, so it's going to be 11.48. 11.48. So try that on your calculator because you need to practice that. Don't be like, oh, well, you already did it for me, so it's fine. It's not fine. Okay, and the next one is going to be 6 minus square root of 30. 0.52, just 0.52, because the 2 is less than 5, so it stays as 2. It's closer to 2 than it is to 3. So 0.52. This is about. Mostly I'm going to ask for this guy right here. The reason I want the exact answer, I don't want to estimate it. I don't want a rounded numbers, right? But for the most, but this is just for you to figure it out on your calculator because I don't want the test to be the first time you try that. That's sad days. I guess another thing I could have thought about was, does 30 go, can I simplify 30? And I'm like, well, I don't think so, but let's just check. 3 goes into 15 5 times. I just have 5 and 1. So yeah, there are no doubles, which means I don't have any perfect squares. This is as simple as it can get. So the answer would be 6 plus or minus square root of 30. If you're like, well, do we need to really check that? I'm like, yeah, you do. It's a thing. All right, and we'll talk about this one tomorrow. See you later.